In this video, we are going to find integers x and y such that x squared times y minus 1 plus y squared times x minus 1 equals 1. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. I'm going to expand the left side, so I have x squared y minus x squared plus y squared x minus y squared, and that equals 1. Then I'm going to group the first and the third terms and factorize. So I have xy times x plus y. Whereas for the remaining two terms, minus x squared minus y squared, I'm going to rewrite that as minus x plus y all squared minus 2xy from the sum of squares, and that equals 1. Now, the left side of the equation is completely in terms of x plus y and xy. Then, at this point, I'm going to rewrite the equation as an equation in terms of a and b by rewriting a equals x plus y and b equals xy, which means ab minus a squared minus 2b equals 1. Of course, I can also remove the brackets. Then I'm going to write this equation with b as the subject. Because by choosing b as the subject, I'll have the other side as a fraction of just in terms of a. And the denominator is only have degree 1, while numerator has degree 2. So I can do some sort of division by splitting the numerator into two parts. The first part is a multiple of a plus 2, or I should say that expression is divisible by a plus 2. And with a squared here, I've picked a squared minus 4. So there is no linear term, just a square term and a constant. And this is clearly a multiple of a plus 2 because this expression a squared minus 4 is equal to a minus 2 times a plus 2 because they are difference of squares. And of course, because I start with plus 1, so that means I have to add plus 5 at the end. Then as planned, this expression becomes a minus 2 plus 5 over a plus 2. The reason that I wanted to do this is that I know that x and y are integers. Going back up, so that means a and b are also integers. Now, I've written b an integer in terms of a, so I have a minus 2 first, an integer, and a very simple fraction, 5 over a plus 2. And more importantly, the numerator is just a small constant. The number 5 is a very small constant, and this fraction has to be an integer. So I've reduced the number of possibilities for a to just a few. That is the factors of 5. Of course, we allow negative numbers, but still very few options, which are minus 5, minus 1, 1, and 5. That's it. So that means there are only 4 possible cases for a, which are minus 7, minus 3, minus 1, and 3. And we can put them one by one into the equation with b as subject. So b equals, when a is minus 7, is actually minus 10. When a equals minus 3, is also minus 10. When a is minus 1, then b is 2. Finally, for a equals 3, b also equals to 2. So now we have a system going back to x and y. I know that for these two integers, the sum is, for example, either minus 7 and then the product has to be minus 10. That's the first system. Or the sum has to be minus 3 and the product has to be minus 10. The second system, and so on. So I can say that x, y are roots to equations either z squared plus 7z minus 10 from the first system, or z squared plus 3z minus 10 equals 0, or z squared plus z plus 2 equals 0, or z squared minus 3z plus 2 equals 0. You may notice that there is no integer roots for this equation and this equation. So we can remove them and just solve the remaining two. And from that we know for the z squared plus 3z minus 10 equals 0, we have z equals 2 or minus 5, and that means x and y, there are two pairs of solutions for x and y because the equation is symmetric, which are 2 and minus 5 and minus 5, 2. That's the first equation. From the second equation, we have z equals to 1 or 2, and that means x and y are either 1, 2 or 2, 1. So these four pairs are all valid solutions, and this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.